Hi all, welcome to my channel. Today we are going to discuss about the data structures. So we are going to discuss about the data structures. So what is the purpose of this data structures? Data structures are used to store the data and it is used to retrieve the data and it is used to process the data. Okay. So data structures are used to store, retrieve and process the data. Basically, data structures are two types. First one is, so basically data structures are two types. First one is linear data structures. Second one is non-linear data structures. So this is a linear data structure. This is a non-linear data structures. Remember, when there is a linear data structure, the data is entered in sequential manner. So what is in the sequential? One after another. In non-linear data structure, the element is not in sequential manner. So one after another in linear. And here the data is sequential in linear. So in linear, the data is sequential, and in non-linear, the data is not sequential. So this is a sequential, this is a non-sequential. Now, so we are going to discuss about the linear data structures. Remember, linear data structures are, again, it will be divided into different types. So first one is linear data structures are divided into different types. First one is stacks. Second one is queue. Third one is, so before stack you can also write array. Stacks, queues, linked list. Linked list. So these are called as linear data structures. So what are those? First one is array. Second one is stack. Third one is queue. Fourth one is linked list. So first we come with the array. So what is meant by array? So first one, let me explain about the array. Array, it is a collection of elements with a similar data type. Collection of elements with similar data type. So collection of elements with similar data type is called as array. So remember, if you want to declare 10 number of elements, you write int a of 10. Okay. So this is called as array declaration. Now this is called as index value. Okay, I want to store 10 numbers. So what I have to do? I need to take the array. So remember, when here n is equal to 10, so index value is starts from 0, 1, 2, 3, so on up to final value is n minus 1. This is a 9. So it is called as array. Array is a collection of elements with a similar data type. Second one, what we have? Stack. So what is meant by stack? Stack is a linear data structure which follows the LIFO. LIFO means last in, first out. LIFO means last in, first out. So stack is a linear data structure which follows the last in, first out. Suppose I want to enter the elements 10, 20, 30, 40. So I want to enter the elements 10, 20, 30, 40, and the size of the stack is 4. So it will take only 4 elements. So remember, there are two operations. First one is called as push. Second one is called as pop. So push means you can insert any element. Suppose when there is a 10, 20, 30, 40 is there, first you need to push 10. So when I push 10, so this will come here. It is a 10 and remaining 4 blocks are empty. Why we are taking 4 blocks? Because here we are assuming size is 10, size is 4, sorry. So next one, push of 20. So push of 20 means 10, 20. Next what we have, push of 30. Okay, 10, 20, 30. Now I can insert one more, push of 40. 1, 2, 3, 4, 10, 20, 30, 40. So this is called as inserting the elements into the stack. What is in my stack? Stack is the last in first out, which follows the last in first out. There are two operations. First one is push, second one is pop. Push nothing but insert the value into the stack. Pop nothing but remove the elements from the stack. Remember, I want to insert one more element. Let us assume push of 50. So we cannot insert this element into the stack because the size of stack is already filled with 4 elements and size is also 4. So remember, if the size is full, you cannot insert one more element. This is called as stack overflow. Stack overflow. When the stack is full, so you cannot insert one more element onto the stack. This is called as stack overflow. Now I can remove the element from the stack by using pop operation. So now what we have to do, we need to insert the values by using stack, and we can use by using pop. Now remove the elements from the stack. Remember, I want to remove the elements from the stack. Now I can use pop operation. So here stack is having 10, 20, 30, 40. So top of the stack is 40. Okay. So in the stack, you can remove the elements from the last in first out. So means here I entered element last 40. So it will be removed first. So you can, when I say pop, in the first iteration, what is going to be happen? It is going to have like 10, 20, and 30. In the next pop, if I say again pop, then what is going to be happen? It is going to have 10 and 20. So like that, all the elements will be removed. So when the stack is empty, this is called, when there is a no more elements in the stack, this is called as stack underflow. So stack underflow means when there are no more elements in the stack. So this is called as a stack. Remember one more important point. When top is equal to when top is equal to -1, stack is empty. So remember important point, stack is empty. So this is called as a stack. So third one, what we have, queue. So what is queue? Queue is a first in first out data structure, linear data structure, which follows the first in first out. So it follows the first in first out. So there are majorly two operations. First one is NQ. Second one is DQ. So when there is a NQ, what will be happening? Insert the elements into the queue. DQ means remove the elements from the queue. So now I can, I want to insert 10, 20 into the queue. So remember, you can use front and rear. This is called as front. So let us assume queue size is 4. So this is front. I can insert 10 here. I want to insert one more element. I can insert here. This is a rare. So initially friend and rare are same. Then friend is this one, rare is this one. So this is called as first in, first out. So next one what we have. So I am going to erase this one. I am going to explain about now linked list. Now what is meant by linked list? Very, very important terminology. Linked list. So here we are using pointers in order to communicate the elements. So in order to store the elements, so there are different types of linked lists we have. First one is single linked list. Second one is double linked list. Third one is circular linked list. So there are three different types. First one what we have, single linked list. So remember what is meant by single linked list. So the elements are moving in one direction. So when here you have only data and pointer. Now I will show the example for the single linked list. So this is called as single linked list. Suppose I want to store the elements 10, 20, 30. When there is a single linked list 10, 20, 30. Remember, I can store 10 here. I can store 20 here. I can store 30 here. So the syntax for the single linked list is first one is data. First one is value. Second one is address. Let us assume this address is 100. Let us assume this address is 200. This address is 300. So this address will come here. It is 300. And this address will come here. It is 200. And we can store one more thing in a header. This is called as 100. So it is a single linked list. So in single linked list only one way moving is there. This is called as a single linked list. So this is called as data. This is called as a pointer. Now we are going to have double linked list. What is a double linked list? So unlike single linked list, in single linked list we have only two values. Now we are going to have three values. 1, 2, 3. 1, 2, 3. So I can store same values. Better understanding. So what are the values we have? 10, 20, 30. So what is going to be happen? This 30. Let us assume this address is 300. This address is 200. This address is. So it stores the address of next location. This is 300. It stores the address of previous location 200. So it will come here. And this is 100. This is 200. So now this is called as a single linked list, double linked list. So in double linked list, the data is moved in this direction. So now this data is stored in again one more thing called as a header. So this is called as a null pointer. So it is called as a double linked list. So in single linked list only one way direction. In double linked list we have double direction. Now when you have circular, so again circular you have two types, circular single linked list, circular. So let us have circular single linked list 10, 20, 30. Okay. So now this is called as circular linked list. So in circular linked list, what happened? Last element is connected with the first element. This is called as a circular linked list. So one of the important point. So these are called as a linked lists. Now let us talk about the nonlinear data structures. So in nonlinear data structures, first one is graphs. Second one is trees. Third one is tables. So first one is graphs. Okay. Second one is trees. Third one is tables. So what is meant by graph? So first we are talking about the graph. Graph is a set of vertices and edges. So G is equal to V comma E. This is called as a graph. Okay. Now, if you see A, B, C, this is called as a graph. Here, vertices are A, B, B, C, C, A. Edges are, sorry, here, vertices are nodes. Anyway, so edges we have A, B, B, C, C, A. So vertices are A comma B comma C. So this is called as a graph. Again, you have different types of graphs in graphs. So simple graph is there, directed. Suppose if I mention arrows, it is called as a directed graph. So second one, what we have, trees. So what is in by tree? Tree is used to store the data, and there are different types of trees we have. So first one is normal tree. Second one is binary tree. Third one is binary search tree. Fourth one is red black tree. Fifth one is AVL tree. So first I will show the example for the tree. 10, 20, 30. So it is called as a tree. So what is in by tree? Tree is a at most tree is a collection of nodes. So you see this is called as root. This is called as a leaf. So what does it mean by leaf? A leaf which does not have any left and right. This is called as a tree. Now let us have binary tree. Binary tree means a binary tree should have at most only two children, 10, 20, 30. Now a root should have, a node should have at most two children. If you see 10 is having only two children. One is this one is this one. Now 20 is having zero number of children, zero number of. So at most, binary tree means at most two children. Okay. Let me take one more example. Suppose you have 10, 20, 30, 40. So remember here 10 is having three children. So you have only at most two, maximum two. So I can say it is a tree, but not it is a tree, but not binary tree. Okay. So next one, what we have, binary search tree. So binary search tree means you can take one more example, 10, 5, 25. So left side value must be less than root. Now left side what we have, 5. Yes, 5 is less than 10, true. 25 is greater than 10, for true. So remember, left side must be less than root, right side must be greater than root. So this is called as a BST. Now what we have, red block tree. So one of the important topic, red block tree. So what is in by red block tree? So here we are going to have two colors. One is red, second one is black. Now remember, always root node must be a black node, and node to continuous should have red node. Now I can give numbers like suppose 10, 20, and 30. Now this is called as, so this is a black node, this is a red node, So this is called as a red black node, red black tree. So what is my red black tree? It is a collection of red and black colors. Always root node should have black color, and node to continuous nodes should have red color. Now last one what we have, AVL tree. So AVL tree I'm going to take in the next part. Okay. AVL tree. So AVL tree means it is having balance factor. So it comes with the balance factor. Let us take the balance factors are 0, 1, 2. Balance factors are 0, 1, 2. So remember what is this 0, 1, 2. Now I can say the elements 10, 5, 13, 17. Now remember, is there this is a AVL tree or not? So now you need to calculate the balance factor left to minus right. So what is the balance factor for 5? 0. What is the balance factor for 17? 0. What is the balance factor for 13? Left to minus right. 0 minus 1. This is equal to minus 1. And here 1 minus 2. This is equal to minus 1. So how I have this 2? 1, 2. How I have this one? This one. So now you see the balance factor are 0, minus 1, 0. Now AVL factor, AVL tree is having, sorry, this one 0, 1, minus 1. So now this is called as a AVL tree. So whatever the thing you have 10, 20, 30. Now you see what you have to do. You need to find out the left to minus right. 0. This is minus 1. This is minus 2. So now you see how you have this 0, left to minus right, no more values. Here left is 0, right is 1, 0 minus 1. Now here no more values, 0, minus 2. So remember, I have minus 2, minus 1, 0. This is not in a red black, this AVL tree. How to do this one? So remember, one of the interesting thing, you need to use the shifting. So when you do shift, you will come like 10, 20, 20, 30, and this will come here. Now this is called as AVL tree. Why? This is 0, this is 0, this is 0. So why this 0? Left to minus right, left to minus right. So I hope this is clear for everyone. Please subscribe my channel, and thank you.